Hey guys, welcome back. So what we're looking at today is 7.3. Can you get there from here? So let's go ahead and jump right in. So what we're going to be looking at is multiple transformations. So having more than one transformation that has to occur on our given figure. So we're going to look at number 3 together. So we want to reflect over the y-axis and then rotate clockwise 90 degrees around P prime. So I'm going to zoom this in and make it real big for us. Yeah, so like I said, we're reflecting over the y-axis first. So P is 2 from the y-axis, so we go to the other side. Let me make these bigger. So there's our P prime. O is 3, so we go 1, 2, 3. N is 1, 2, 3, 3 further from O, so 1, 2, 3. M is 1, 2, 3, 4, 5 from P. So 1, 2, 3, 4, 5 from P. K is 3 from it. So it'd be right there. And then L is 1, 2, 3 further. So 1, 2, 3. So there is our first image. Let me draw the lines in between. Hopefully. So we've got our image. Whoa, that line was way off. Sorry. So my lines aren't the straightest, but you get the idea. So these are all the prime values. So this would be P prime, this is O prime, N prime, M prime, so on and so forth. So now we want to take a look at, let me change the color, at rotating it 90 degrees clockwise around point P. So P is going to stay exactly where it's at, or around P prime, sorry. So P prime is going to stay exactly where it's at, and we're rotating it clockwise. So that means K is going to end up over this way. So remember, it's perpendicular. So before we went up 1, 2, 3 and over 1. And so now we want to go over 3, 1, 2, 3, and up 1. That gets us our 90-degree rotation. Now, we know that the relationship between K and L, they are in a straight line with each other, so that's going to continue. So it's going to be 1, 2, 3 above. So 1, 2, 3 above. There's L double prime. Now, between M and L, it's down 1, 2, 3 over 1. So we're going to go up 1 and over 1, 2, 3. There's M prime. N prime is down 2 over 1. So down 1 over 2. There's N. O is going to be straight down from that 3 units. So 1, 2, 3. There's O. And then we're back at our P prime. So there is our image after another set of transformations. So looks something like that. And this would be L double prime, K double prime, M double prime, N double prime, O double prime. I know there's not a lot of space in there for writing the primes, but that's what this is going to look like. So sometimes they are going to end up kind of on top of each other, so you have to be kind of careful. Using different colors, kind of like I did now, helps you separate between the different constructions that you're doing, so it makes it a little easier, but be very careful when doing these. All right, so now we're going to take a look at the set. So find the sequence of transformations. So now we have both the images, and we need to figure out how did we get from one to the other. So sequence is your key word for this lesson, sequence. So find a sequence of transformations that will carry triangle RST to triangle R prime, S prime, T prime. Clearly describe the sequence of transformations below each grid. So we're looking at number 6. Oops. So how did we go from this triangle here to this one here? Well, we know that it moved over to the left, because it went from here over, and S is still in the same spot. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So translate triangle R, S, T, 8 to the left. Now, how did we end up with R down below? Well, we reflected, right? That's the only way that it could be flipped like that. So we reflect across S prime, T prime. So R lands with R prime. So you can use the fact that we have these points. So I could have said translate S to S prime without saying how far we went. That is a completely acceptable thing to do. It's a nice way, being as we have the actual image and pre-image, we have both of them. We can say that we're moving this point to this point, or this side to this side, and so forth. All right, our last section, graphing systems of functions and making comparisons. So we want to graph each pair of functions and make an observation about how the functions compare to one another. So number 7, we have y equals 1/3 x minus 1. So make this bigger. So our y-intercept is -1 on both of these. So we're going to start right here at -1. Now for the first one, our slope is 1/3. So we're going to go up 1 and over 1, 2, 3. Up 1 and over 1, 2, 3. Up 1 and over 1, 2, 3. Now come back here and go down 1 and over 1, 2, 3. Down 1 and over 1, 2, 3. Down 1 and over 1, 2, 3. So there is our first line. I'm going to try to draw it between the points. Now, for our second line, let me change the color real quick. We are looking at -3x minus 1. So we start at -1 again. But this time we're going to go down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. Come back to our y-intercept and go up 3 and over 1. 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 So now we have our second line. Now, what can we distinguish about these? What do we know about them? How do we compare them? They are what kind of lines? They're perpendicular. So these are perpendicular. And so it's a 90-degree rotation to go between them. So we can tell that both from the fact that they make a right angle here, as well as if we look at the slopes, they are opposite reciprocals of each other. Okay? All right. We are also going to do number 10 together because this is a little bit different of a function. So if we plug in values, if we plug in 0 to this, we're going to get 1 no matter what. So we get 1 for this first one. If we plug in 1, we get 2. If we plug in 2, we'd get 4. If we plug in 3, we'd get 8. 4, 5, 6, 7, 8. And if we plug in 4, we'd get 16, but we can't go that high. So there's our curve. So these are going to be a curve because they're exponential. So this is going to look like this. And it's going to approach the x-axis but never cross. Now, for the -2, because the negative is not contained within the power of x, that means that our answers can be negative. So -2 to the 0 power is going to be -1. 1 or -2 to the first power is going to be -2. -2 to the third power, the second power, got off there, is going to be a -4. And then we'll be at -8. So 4, 5, 6, 7, 8. So very similar to what we just did. Yes? Yes. They are just opposites of each other. So this is going to go down this way. This is going to approach the x-axis but never cross. So what do we notice? Well, they're flipped, right? So it's a reflection across y equals 0. So that is their comparison there. All right, if you guys have any questions, feel free to ask. Have a great day.